अस्सलाम वालेकुम रहमतुल्लाह। कल के वीडियो में हमने पढ़ा था लॉज ऑफ रिफ्रैक्शन एंड डायरेक्शन ऑफ बेंडिंग ऑफ लाइट. So when light goes from rarer medium to denser medium like this is rarer medium, medium 1, this is medium 2 is denser medium, medium 2. When light goes from rarer medium to denser medium like this, A is the incident ray, O is the point of incidence. First it slows down and it bends towards the normal. जो हमने कल पढ़ा था, कल हमने इसको प्रूव किया था by using Snell's law of refraction. It bends towards the normal. When light travels from rarer medium to denser medium, it slows down, its velocity decreases when it reaches the second medium, denser medium, and it bends towards the normal. और इसके बाद हमने ये भी प्रूव किया था converse of this, यानी when light travels from denser medium to rarer medium like this is the denser medium to rarer medium, it speeds up, its velocity speeds up when it enters the medium 2, medium 2 or denser, rarer medium, and it bends away from the normal, Here I is lesser than R is greater than I in first case. In this case, when light travels from rarer denser medium, R is less than I. In second case, when light goes from denser medium to rarer medium, R is greater than I. So refracted ray bends. Refraction angle of refraction is greater than angle of incidence in this case when light goes from denser medium to rarer medium. So when light goes from denser medium to rarer medium, it speeds up and it bends away from the normal. ये हमने कल पढ़ा था. आज जो पढ़ना है वो है, इसको हम प्रूव भी करेंगे by using this Snell's law of refraction. This is the topic is conditions of no refraction. What are the conditions under which no refraction of light takes place? The conditions under which no refraction of light takes place, there are two conditions. Under which no refraction of light takes place. Two conditions under which no refraction or no bending of light takes place, no deviation of light takes place. So these two conditions, our first condition is when the light is incident normally on a boundary. When the light is incident normally on a boundary. Boundary means the boundary, and it means the line of separation, the interface which separates the medium 1 and medium 2. So one condition is when light is incident normally on a boundary. So इसको हम prove भी करेंगे by using Snell's law of refraction. So this is the boundary xy or interface which separates the medium 1 and medium 2. So this is the incident ray is along the normal. Incident ray is incident, the light is incident on the normal, along the normal. So this is NO normal, this is also incident ray AO. Since no angle of incidence is formed, angle I is 0. The angle between the incident ray AO and the normal NO, N dash, that is angle of incidence, that is 0. Angle of incidence, here angle of incidence is 0. अब हम इसको यहाँ पर अप्लाई करेंगे Snell's law. Snell's law states that sin I divided by sin R is equal to, इसका रेफरेंस इंडेक्स हम लेंगे μ2, इसका रेफरेंस μ1, so that is equal to μ2 divided by μ1. रेफरेंस इंडेक्स of 2 with respect to 1, it is written as μ21. और इस ऐसे भी रिप्रेजेंट करेंगे μ21, रेफरेंस इंडेक्स ऑफ 2 with respect to 1. So yes, so और निकालने के लिए हम इसका रेसिप्रोकल लेंगे sin I डिवाइड sin R, यानी sin R डिवाइड sin I, इसके रेसिप्रोकल के बराबर होगा μ2 डिवाइड μ1, यानी μ1 डिवाइड बाई μ2. अब मल्टीप्लाई करेंगे, क्रॉस मल्टीप्लाई sin R इज इक्वल टू μ1 डिवाइड बाई μ2 sin I. ये मल्टीपल हो गया, यहाँ पर मल्टीपल हो गया इसे. So sin R μ1 divided by μ2 sin I is 0, sin 0 is equal to 0, sin R is equal to mu1 divided by mu2 into 0, sin 0 is equal to 0, so it will become a 0, this RHS sin r equal to 0. So when is sin 0, when minus sin when is sin of any angle 0, when angle is 0, so sin 0, so r is equal to 0. ऐसे भी लिख सकते हैं r is equal to 0, sin cancels, r is equal to 0. So here it then the reflected ray is in line with the incident ray, so it follows, it passes undeviated. When it enters the second medium, it passes undeviated. There is no refraction of light takes place. R is equal to 0. R is also equal to 0. I is 0. R is also equal to 0. So no refraction of light takes place when the light is incident normally on the interface which separates the medium 2, medium 1 from medium 2. This is the first condition. अब second condition जो है, second condition हम लेंगे हम दो मीडियम्स हम लेंगे, मीडिया उनका जो रिफ्रैक्ट इंडेक्स है वो सेम लेंगे. उस केस में भी नो डेविएशन टेक्स प्लेस, नो रिफ्रैक्शन ऑफ लाइट टेक्स प्लेस. सो व्हाट इज द सेकंड कंडीशन under which no refraction of light takes place? When the two media in contact have same refractive indices. When the two media in contact have same refractive indices, plural of index. So हम ये ऐसे लिखेंगे हम, this is the interface, this is the boundary xy which separates the medium 1, medium 2. This is the n dash normal. This is the incident ray. This it is mu index mu1. This index of 2 is mu2. So mu1 equal to mu2. Suppose they are same, that they have the same index, that is mu. It is index is mu. This is its index also mu. So here I is formed, I is angle, AO is the incident ray, like this, AO is the incident ray. So using Snell's law states that sin I dot sin r mu2 जिसमें रिफ्लेक्शन होता है mu2 divided by mu1, sin I divided by sin r mu2, mu ये दोनों mu के बराबर हैं, mu divided by mu cancel equal to sin equal to 1, sin I divided by sin r equal to 1, क्रॉस मल्टीप्लाई करेंगे, sin I is equal to sin r, sin sir cancel, I is equal to r. So I and r, the angle between the incident ray and the normal, and angle between the incident refracted ray and the normal, they are the same. I and r are the same, so there no deviation takes place, no refraction takes place. In reflection light, I is never equal to r, but here I comes out equal to the r, so it is not the refraction, it is not refraction. So no deviation light takes place when the two media in contact have the same refractive indices. No refraction of light takes place when the two media in contact have same refractive indices. So these are the two conditions, the conditions under which no refraction light takes place. Number first is when the light incident normally on the boundary which separate the medium 1 and medium 2, and second condition is that when the two media which are in contact have the same value of refractive indices. In these, under these two conditions, no refraction of light takes place. So we have now proved that by these two conditions, by using Snell's law, refraction, no refraction of light takes place when light is incident normally on the boundary, and second, when the two media in contact have the same refractive indices. And thanks.